So typically when we're dealing with trigonometric identities, there are two types of questions that we'll come across. The first type of question is what I did in my last video. So that's where you're given an expression. So let's say sine squared of x minus 2 sine x cosine x is equal to 0, and you're asked to solve for the value of x. Now I did this question in my last video. And the second type of question will be where you're given two expressions and you're asked to prove that one is equal to the other. So for example, we're asked to prove over here that 1 plus sine of x whole squared plus 1 minus sine of x whole squared plus 2 cosine squared x is equal to 4. Now what we have to do here is we have to change the variables or move around the variables on one side, so typically the side on the left, in order to prove that it is equal to the side on the right. So you have to prove that this is equal to that. And the way that we do this is we can just move around variables and try to open stuff up. So let's start by opening up our squares. So we get 1 squared plus 2 sine x plus sine squared of x plus, and then in brackets, 1 minus 2 sine x, so we're opening up this, plus sine squared of x plus 2 cosine squared of x, and then this is going to be equal to 4. So we can further open this up. We get, you'll notice plus 2 sine x is over here and minus 2 sine x over here. So we get 1 plus sine square x, so these two cancel out, and then plus sine square x again, and then plus 1, forgot about that one, and then plus 2 cosine square of x is equal to 4. Now you're probably already noticing that we have sine of x, or sine square of x, and cosine square of x, so we'll have to do something to merge them together in order to use our identity. So what will we do? We have 1 and 1 is 2, and then 2 plus 2 sine square x plus 2 cosine square x is equal to 4. 2 plus 2 times, then we once again want to get our identity, so sine square x plus cosine square x is equal to 4. So this right here is our trigonometric identity. We know that sine square of x plus cosine square of x is equal to 1 for any value of x. So 2 plus 2 times 1 is in fact equal to 4. So once again, in this type of question, what we have to do is we have to move around the variables and open up brackets and do whatever we need to do in order to find some trigonometric identity through which we can prove that the two expressions are equal to each other. Let's look at another example. So let's say that we have to prove that 1 over cosine of x minus cosine of x is equal to sine of x times tan of x. Now the first thing we want to do is to combine these two expressions, because on the right side of our, or on the left side of our equation, actually, we have a minus sign, and there are no minus or plus signs over here, so we want to make this into one expression. So to do that, we do 1 over cosine of x minus cosine of x times cosine of x over cosine of x, so we give them the same base. Then we get 1 over cosine of x minus cosine squared of x over cosine of x. This gives us 1 minus cosine squared of x over cosine of x, and we're supposed to prove that this is equal to sine of x times tan of x. So now what we have to do is we have to look for whatever identities we're able to apply over here. So you probably noticed we have a 1 and a cosine squared of x, and this ends up working such that 1 minus cosine squared of x, so cosine squared of x is equal to sine squared of x. And that's simply by moving this expression onto the other side of our equation. So we end up getting sine squared of x over cosine of x. And then we can simplify this. We know that since we want to get tan of x, we know that sine over cosine is tan. So we want to somehow get sine over cosine. And we do this by writing sine of x times sine of x over cosine of x. And I guess we can write this separately. And this will give us a value of sine of x over cosine of x is tan. So we get tan of x times sine of x. And as such, we prove that these two expressions are equal to each other.